show where I interview famous scientists throughout history using advanced holographic technology to make it appear like they're actually here. I'm here tonight with a very special treat for our viewers. I've invited the Nobel Prize-winning geneticist, Crick, to talk with us. Happy to be here. Okay, well, obviously you are a great scientist. How did you come into this field of study?
That's a good question. Well, you see, science has always appealed to me. I earned my bachelor's degree in physics from University College London, and I worked for a while during World War II developing radar and magnetic mines.
Really? That seems, like, far from your work with DNA. What inspired you to work with Mr. Watson?
After that, I began research at Cavendish Laboratories under two biologists. I had been working on my dissertation on X-ray crystallography for a while, and Watson had already been studying DNA when he came to Cavendish. We began making large-scale 3D models of DNA structure, determined to discover what the actual structure looked like.
Was this, like, a quick process, or did it take a while for you two to figure it out?
You have to understand, many scientists at this time were trying to figure out the structure of DNA. Watson and I were actually in an unofficial race to discover it after Linus Pauling, another scientist, proposed an incorrect structure or model of DNA. Now, that was in early 1953. We came up with the solution in February of that same year, although it wasn't published until April.
Please, Mr. Crick, explain to the audience what the structure of DNA looks like.
So, we discovered that DNA is composed of a double helix. This means that it has two strands of DNA, each composed of nucleotide monomers. These strands wrap around each other, linked together by nitrogenous bases. Now, this discovery was monumental because it solidified our theory about DNA replication in that the strands separate during replication and serve as the template for the new strand of DNA.
That is fascinating. Now, with so many other scientists competing for the solution, you two clearly had something that the others didn't.
Yes.
So, what was the breakthrough that led to this remarkable discovery?
Well, funny you should mention that. Another scientist that helped me greatly with this was Rosalind Franklin. Her work in X-ray crystallography was actually what solidified the structure.
I heard that there has been some controversy surrounding your work with Rosalind Franklin. Care to elaborate?
Really, it is an unfortunate circumstance. A colleague of ours, Maurice Wilkins, had shown us some of her X-ray pictures of DNA without her permission. Now, unless you've studied X-ray crystallography, which I had, if you remember, I did my dissertation in it.
I recall.
You can't understand what the resulting image shows. However, I was able to decipher it, and that's really ultimately what led to our pivotal discovery.
And this is what you, James Watson, and Maurice Wilkins won the Nobel Prize for, correct?
Yes, but unfortunately Miss Franklin died of ovarian cancer before the award was presented to us. Her name was not on the paper that we published either, so she did not get the credit that was due for her important role in this discovery.
Now, just to put your work into perspective, would you mind telling us what the field of genetics was like before your group's discoveries? Obviously, we didn't know much about DNA structure, but surely we knew some things about it.
Well, we've known about the existence of DNA since the 1860s, and we've been studying it since. In 1943, it was discovered that DNA had an imperative role determining genetic inheritance. The bacteriophage experiments run by Alfred Hershey and Martha Chase solidified the fact that DNA was the genetic material, as opposed to proteins. From the scientist Erwin Chargaff, we knew that the percentages of base pair A matched with base pair T, and the same with G and C. This was crucial in our understanding of the structure of DNA. Our research and work was built on years of previous discoveries.
Let me just say, your work has been a gift to the fields of genetics and medicine.
Thank you.
It has led to scientific advancements and has sparked tons of new genetic research that wouldn't be possible without your contributions. Without this, we would not have such crucial scientific advancements such as DNA testing, prenatal screenings for genetic diseases, genetic engineering, and so much more.
Well, thank you. It is great to hear that our work has led to so much great research and advancements.
Well, unfortunately, that's all the time we have for today. Thanks for coming, Mr. Crick.
Thank you for having me.
Off you go.